Good evening, guys. This is Dalton Mutebi, again presenting vibe coding. So, last time we had looked at the the topic about context windows and tokens and how AI models end up hallucinating by the middle of their context window. They tend to forget what you had introduced in the first place, and also the model becomes inefficient. It becomes like a dumb chatbot, and yet it was, in the first place, a very intelligent machine to work with. So, let me introduce what I'm going to talk about today. Let me share my screen now. Are you guys seeing my screen? Anyone? People. Okay,
Yeah,
that's
bro, we are
good.
seeing it.
Okay. So, right now, I'm going to introduce multi-agent systems. So we all know that an AI agent is an improvement of an LLM, but an LLM before would just send you text, you tell it something, and it just replies to you using text. It can't implement any decision, though some developers decided to introduce what they call function calling to LLM APIs, which could cause an LLM to ask you that it should execute something, but it wouldn't actually do that thing. That's where we came up with the thing of AI agents. An AI agent is better than an LLM API with function calling. Function calling means that an LLM can go search something and find what action it must do and then ask for you to do it. But an agent can do it without your approval, which is why the agent comes as a key player in executing complex workflows. But an agent alone cannot be efficient, because even though an agent is like an improved version of a chatbot or an LLM API with function calling, it cannot work alone because there is also a risk of hallucination. That's where the multi-agent systems come in. So here we see that we make teams of autonomous AI. We move beyond single prompt restrictions and discover how specialized orchestrations of models collaborate to solve operational challenges. So, last week I've talked about the recap for last week. I won't go through that. So, what we should know is that if there is a complex task that overwhelms a human, you alone cannot finish it. In most cases, we assemble a team like how you see here at DeepMinds. We are studying various aspects of AI. As a single person, it would be almost impossible to exhaust them, which is why we were set up to discuss all those various stuff. and come together and form a team of knowledgeable individuals, mainly focusing on the field of AI and also those other fields all of our comrades took up, like probability, quantum computing, prompt engineering, and those others. All of them, when they come together, they form an important piece. Each individual piece forms a key aspect of the other. When you are to work alone, it is almost impossible to give equal attention to each of the various fields we were given. So that's why here also multi-agent systems come in place so that it can check on the work which was done by another agent and also plan and also execute a workflow or even assist in the orchestration. So what is a multi-agent system? It's a dynamic ecosystem of specialized artificial personas working in coordination. The picture you see here is like an example of a company. So a company can do various roles: wealth management, financial planning, tax advisory, corporate finance, and risk management. All of these fields, it is impossible, maybe for these startups which have like two people, it is impossible to have all of these roles being done by one person. So for a company to progress and also for any venture in this world to progress, or any group of people who have come together to do something to progress, they must have a way of working together and understanding each other and evaluating the work which was done by the other. So what you should know here, multi-agent systems work in that way, which is why some people have found a way of causing companies to adopt such systems, which is why you hear they have a way of replacing employees. But it also cannot be valid because a human is always needed in the loop. Multi-agent systems always deploy discrete, hyper-specialized configurations of models that converse, critique, and hand over structured data payloads. Each agent functions as an independent employee, operating with restricted context, direct data access tools, and specific execution parameters to maximize procedural reliability. So single models fail at complexity because of overload. A system prompt When a system prompt asks a model to simultaneously process 15 distinct rules based on logically and format the output, the performance of that agent degrades sharply. So the model begins ignoring critical constraints. I also talked about hallucination, where the agent could make a logical error and that logical error stays, and it is made constant in the following steps, which makes almost the whole workflow wrong. It is like how we have these numbers in our exams, whereby if you get a wrong answer on part A, the rest of the answers are wrong, no matter what you do. So an agent would find it hard to critically evaluate its work because it might have bias. Because these machines, they value a lot in like praising what they have done. They cannot properly critique themselves that they have done something wrong. So a critique would be best named as another agent which isn't that agent which has been doing all the work. Anatomy of an AI team: we could have a planner. It receives unstructured human input, builds step-by-step logic, trajectories, and routes specialized subtasks. We could have an executor, the one which carries out the task prompts using specific tools and API keys. We could have a critic that audits the completed work. So here we have a table evaluating the various AIs which are in the field. We have crew AI, and it has role-based task execution, and its control level is medium. So there's also AutoGen, LangGraph, and many others. I haven't listed all of them. So the workflow design methodology of an AI team, you define the output and also map the bottleneck where a single prompt drops or lacks dynamic reward access, because sometimes a user might not know what their request might be required to do. We profile personas, we write modular system, prof- separating generation from evaluation, and also state the handoffs. You define the explicit communication standards to cleanly transfer assets between stages. So we have an example of a multi-agent architecture workflow here, like an institutional research team. You have a web scraper agent that utilizes query APIs, a data analyst agent that reads this unstructured text, and copywriter agent that shapes these numbers into an executive brief, while a critique agent cross-references the sources to eliminate false information. So there are also risks in these things of multi-agent systems. You could have an infinite generation loop. The thing I mentioned of a mistake being made and then the mistake being kept throughout the workflow, creating an infinite loop of a critique, like saying that the thing which has been output is wrong, and then it doesn't know what to do after that step. And also, when you have multiple agents, that token expenditure increases because you are having like three brains working on a single task. So you had some recent news whereby Copilot introduced something connected to token tracking, and people were spending their monthly tokens in 3 days. I hope some of you had heard about that. I think it's connected to multi agent systems. Like there are trade offs because not everything can be always good. So you could do this on your own. Let me just show you some sites which you could go on to try this out. Could build and also orchestrate your team, identify a complex, repetitive, multi-step workload, and create personal system plots for at least two autonomous agents. Uh, I used to use N8N, but I think the only option to use it for free is for 2 weeks, and then they force you to start paying. Otherwise, if you want to try that out, you could go to these sites, AI Studio, and also Copilot. Yeah, you could try out that on your